Hey everyone, welcome back to the channel. Today we're diving into Base64. Let's get started. So, what exactly is Base64? It's a way to convert binary data into a text format using 64 printable ASCII characters, A to Z, AZ, 0 to 9, plus, and slash. Introduced in 1992 as part of the MIME specification, it solves the problem of sending binary data, like images or files, over text-based systems like email or JSON. For example, the string here will become this unreadable string in Base64. This text string is safe to send anywhere, no matter the platform. Curious how that happens? Let's break it down. First, convert it to binary. Every character is represented by its UTF-8 encoded bytes. UTF-8 is a variable length encoding, so we need to determine the byte sequence for each character. For Tim, we can look up the ASCII table to find each character's value. The uppercase T corresponds to the decimal value 84. Lowercase I corresponds to the decimal value 105. And the lowercase m corresponds to the decimal value 109. Then we can convert the decimal value into binary. For the smiling face emoji, first find the Unicode code point here. In hexadecimal, this is 1F642. Convert it to binary and pad it with the leading zeros. To fit the UTF-8 encoding for a 4-byte sequence, uses the template where the XXX bits are filled with the binary representation of the code point. Map the bits to the UTF-8 template one by one. So here, we converted the string to its binary representation. Next, we will group the bits into 6-bit chunks. Base64 requires the input to produce a number of 6-bit groups that correspond to a multiple of 4 output characters. To make the bit count divisible by 6, we pad the input and add 4 0 bits to the end. This gives us 10 full 6-bit groups, which will produce 10 Base64 characters. Now, map 6-bit values to Base64 characters by looking up the Base64 table. So, here is the Base64 characters so far. We need to ensure padding aligns with Base64 rules, which the output must be a multiple of 4 characters. Thus, we add 2 padding characters at the end. And here is the result. Why bother with Base64? Here are the use cases. Text-safe transfer, perfect for systems like email or APIs that only handle text. Embedding data. Embed images or files directly in HTML, CSS, XML, or JSON. No extra server requests. Cross-platform compatibility. Works seamlessly across languages and platforms. Available in every major programming language. Here are the limitations. Larger size. Base64 increases data size by about 33%. A 1 megabyte file becomes a 1.33 megabytes, so it's not great for large files like videos. Performance cost. Encoding and decoding use CPU resources, which can slow things down for big data sets. Not for text. If your data is already text, Base64 just adds unnecessary overhead. Not secure. Base64 is encoding, not encryption. Anyone can decode it. Standard Base64 uses plus and forward slash, which can cause issues in URLs or file names. That's where variants like Base64 URL come in, swapping plus for minus and forward slash for underscores. It's a small tweak, but a game changer for web APIs. Here are some of the variants. Why choose Base64 over other methods? Base32. These use fewer characters, so they're less compact. Base128 needs a larger character set, including non-printable characters, making it less compatible. Base64 hits the sweet spot for text-based systems, balancing compactness and compatibility.
So, there you have it. That's Base64 in a nutshell. Thanks for watching. Hope you find this video helpful. See you next time!